All right, guys, so we're going to go on and get started with the lesson today. The lesson today, I think that y'all will find it actually a lot easier than some of the lessons we've been doing, and we're definitely not going to go through every single example problem because we just won't need to.
Yeah, you got any Kleenex?
I do not. Okay. All right, guys. All right, guys. What we're doing today is actually not that difficult. What we're starting with is solving radical equations. And solving radical equations is really, we're going to do 3 steps, and we're going to be able to solve most of these here. And it's all revolving a little bit around this here, squaring each side of equation. If 2 equations or 2 expressions are equal, then if we square both sides, they're still going to be equal. So if a is equal to b, then a squared is equal to b squared. So if we said 2 is equal to 2, well, 2 squared is still going to equal 2 squared. So we can square both sides. Is really all this is saying. Now we look at the first equation. I'm going to end up rewriting this in the dead center. I need to fix those note sheets because, as I realized first hour, that's equation is way too close to the side of the screen. Is this here? Now our first main step in solving this is to get the radical by itself. All right, guys. Our first main step is to get the radical by itself.
You make fun of Reed today.
Yeah, he fell asleep.
That's bad.
If there's more than one, even them out. If there's more than one, even them out. Now, for the first few, that's not really going to come into play, but when it does, it'll make a little more sense. So our first main step is to get the radical by itself. So I'm going to rewrite this in the center. Okay. Is the radical by itself? Well, no, we have the plus 5, yes? So what do we need to do to get the radical by itself? Yes. So 13 minus 5 is 8. Do we have the radical by itself? Okay. Now that brings us to step number 2. Put both sides to the nth power. And what we're doing with this step is to really simplify that radical. Well, what power do I need to simplify a square root? 2. So we can square both sides. Now, realistically, what we're doing with this here, which we don't really state, is that x, the square root of x, is really the same as x to the 1/2. Or the nth root of a to the x, rewriting it as fractional exponent. And when we apply that power of 2, well, we're really just multiplying 2 and 1/2. 2 times 1/2 is, so we just have x. But as we like to use our shortcut, we're really just saying that the square root and square cancel, which tells us x is equal to 8 squared is a little bigger than that. And that's it. Now, do we need to add the plus and minus with the 64? Well, no. Now, the reason I bring that up is because if we said that we had x squared is equal to 64 and we took the square root of both sides, then we would need to say that x is equal to plus or minus 8. Because when we take the square root of both sides, we're really trying to see what number times itself is 64. Well, 8 times 8 is 64. Negative 8 times negative 8 is 64. Here, we're going the other way around. We're really just saying 8 times itself is what? 64. The square root of what is 8? Now, the square root of negative 64 won't get us back to 8. It would get us to 8i. It's not a real number. So here we don't need the plus or minus. It's just going to be 8. Or here it's just going to be 64. And that's it. Questions on this here? All right. So I'm going to put this in the center, so I'm not writing this on the absolute side of the screen. Now, our first step is to what? Get the radical by itself, yes? What can we do? We can minus 3 from both sides, which would tell us that negative square root of x is equal to is the radical by itself. It has a negative. So we do need to get rid of the negative. How can we get rid of the negative? We can divide by negative 1. I mean, we could have also multiplied by negative 1. We got the same thing, which is really just telling us that the square root of x is equal to. So now the radical is by itself, yes? So step number 2 is to take put both sides to the nth power. Well, our power in this case would be 2. That's it. If we wanted to go back and check, we can. And if we were checking these, it would just be saying that 3 minus the square root of 9 is equal to 0. And again, if it says to check it on the test, those are some of the easiest points. It'd be nice to have that on the test. Because literally, if I wanted to check it, first thing I do is write this here. I can say, check 3 minus 9 equals 0. 0 equals 0. Check. There's a point. Because it's just verifying that, yes, it does work. It is the correct answer. And it does help us to make sure that we did it right. And that's all we got to do to check it. Because square root of 9 is 3. 3 minus 3 is 0. Okay, it does work. And the big reason we're going to check, it won't be too much today, but we can't have a negative inside of a radical, inside of an even root. We can't take the even root of a negative number. This one's even nicer. Is the radical by itself? Okay, so we can go on to step 2, put both sides to the nth power. So we'd square it exactly. So x is 36. That's it. Any questions on any of this here? All right, guys. Any questions on these here? We like these here? Yes? Okay. if we feel comfortable with these here, we'll move on because I put extras in here just in case we need to see more of them. Just in case y'all need to see more examples or kind of reiterating how this works, I put more in here.
We're glad you're always one step ahead.
Now, this one here has a few more steps to it. But again, we'll have to add a third step, but it's not really adding anything to it. But our first main step, like we've been doing, is to get the radical by itself. So the first thing we can do in getting the radical by itself is to what? Well, minus 3, because we want to do addition subtraction first. Exactly. It'll tell us that 4 square root of x plus 2 is equal to 16, because our 3 minus 3 would give us 0. So we have the x plus 2 at the radical, but we need to make sure we get what? The radical by itself first. So we would divide both sides by 4. Because to undo the multiplication with the 4 in the square root, we need to divide. Because 4 divided by 4 is 1, leaving us with the square root of x plus 2 is equal to 4. Any questions on this so far? So it's not too different than what we did on the previous ones. We're just moving everything away from the radical. Is the radical by itself? Because we do have x plus 2, yes? But where is the x plus 2 located? Inside the radical. Now, another way to look at this is really we say, or we're saying that we have x plus 2 to the 1/2. That entire expression, x plus 2, is contained inside that radical. We don't have to write it this way as x plus 2 to the 1/2. I'm writing it this way for y'all to be able to see these are the same expressions. These are the same equations. So when we come over here and say that we're going to take both sides to the nth power, here the second power, well, as we use our little shortcut and say that these cancel out, or as I keep trying to erase everything, it will leave us with just x plus 2. And 4 squared is 16. And the reason this works is, again, our half exponent and the 2 multiply together to give us 1. They cancel each other out, or simplify each other out to tell us that x plus 2 is equal to 16. That's why this works. That's why this works the way it does. Right, and the last step, step number 3, is the complicated step of solve. Because we really haven't needed it up to this point, because if we noticed all the previous ones, once we squared both sides, the variable was already by itself, and we were done. Here, we're just having to subtract 2, telling us x is equal to 14. So did that one really add anything to what we were doing previously? Not too much. Because all we had to do was get the radical by itself, square, solve for x. Any questions on any of this here? Any other questions on this right here? We feel comfortable with these? For the most part, yes? Let's look at this one here, because we have a division inside the radical. Not division, but we have 3w inside. So we'll skip a few, I think one more page. I did include a several in here. But this is the last one of this type before we move on to the next one. But the overall process doesn't change because, again, we want to get the radical by itself. And to get the radical by itself for this here, the first thing we're wanting to do is to minus 6 from both sides. Now 15 minus 6 is 9 is equal to square root of 3w minus 9. Well, what do we need to do next? Square it. We need to square both sides. Well, the square root and square would cancel, leaving us with 3w minus 9. 9 squared is 81. What would our next step be? To add 9. And when we add 9 to both sides, we get that 3w is equal to 90. So that's kind of convenient. Because our last step is to divide by 3, telling us that w is 30. I say that's convenient because it works out to be a nice even number instead of having some ugly decimal, especially with thirds. But any questions on this here? I mean, out of all the stuff we've covered in chapter 5 so far, I think y'all like this probably second best. I think the first one was the ones you can plug into the calculator. This one looks a little different because how many radicals do we have this time? Two. Okay, well, in our steps, because the first step was to get the radical by itself, our kind of sub-step, if there's more than one, even them out. If there's more than one, even them out. And what that means is we want to get an even number. We want to split them up. We want to have them divided evenly. So since we have 2, I want 1 on either side. Or if we had 4, we would want 2 on either side. We want to try to keep them even, both sides. Not say an even amount, 2 and 2, but we want them split up. So here, we want to have 1 on each side. Now up to this point, our next step would have been to what? Put both sides to the nth power. So here, we're going to put both sides to what? Second power, because they're still radicals. They're still square roots. And let's see what happens if I put both sides to the second power. Well, the one on the left, the radical and the square both cancel, leaving me with 2x minus 1. The other side, the radical and the square cancel, leaving me with all the radicals are gone. Because squaring both of these cancels out with those square roots. Solve for x. So at this point we can subtract x from both sides. Because 2x minus x is x. And then we can add 1, telling us x is equal to 5. That's it. It's kind of nice when we have a radical on both sides, yes? As we square it, the radicals are gone, and we're back to solving linear equations like we did in Algebra 1. But that's it. That's it. That's all we have to do for this here. Questions on this here? Well, I don't think we're in dire need to see one like this because we square it and solve. How about this one here? Yes. Now, it'd be very tempting to want to square both sides. It'd be very tempting to do this. Now, if we squared the left-hand side, we have how many things inside those parentheses? 2. We have to distribute if we do it this way, which means that I'm going to be taking 3x plus 1 minus square root of 4x minus 7 times the square root of 3x plus 1 minus square root of 4x minus 7. Because whenever we have two things inside a parentheses squared, we're having to use this distributive property. Okay, let's erase that. Because step 1 was to get the radical by itself, yes? Our sub-step was what? If there's more than one even amount, yes? So we've got 2, so it'd be nice to have 1 on either side, yes? Root of because the square root of 4x minus 7 is just a term, it's an expression. Because if we add something that's being subtracted, they cancel out. Because I have 1, a negative of the 4x minus 7. If I add a positive 1 to it, this becomes 0. Telling me that I have the square root of 3x plus 1 is equal to the square root of 4x minus 7. So when we have 2, no matter what else is there, we want them on either side. We want one on either side. It's going to be a lot easier to work with if I only have 1 on either side. The only time we would ever want to leave 2 radicals on the same side is if we have a total of 3 in the equation, where no matter how I set it up, I'm going to end up with 2 on one side or the other. If I only have 2, I want to put 1 on either side. And then we can go back to using the nth power. Because we only have 1 in each side, we only have 1 term, we're just multiplying it by itself, which means this radical and square will cancel, telling us that 3x plus 1 is equal to 4x minus 7. And now we're going back to what we did previously, just solving for the value of x. And the first thing we can do here is to subtract 3x from both sides. Because 3x minus 3x would be 0, telling us 1 is equal to 4x minus 3x is x minus 7. And last but not least, we can add 7 to both sides, telling us x is equal to 8. And that's it. That's all we have to do for these here. Any questions on any of these here? So we kind of like the first ones we did where we just have the square root, just got to get it by itself and solve. These here are not that bad. If we have 2, get them on either side, square it, and then we can solve. These here are the last type that we're looking at. But what makes this different than the ones we've done? Do we have a square anymore? No, we have a cubed root, yes? So let's look at the steps we did for the square roots and the ones we've done so far. The first main step is to get the radical by itself, yes? Is the radical by itself? Yeah. Because we have the cubed root of 5x minus 2 by itself. Now our next step was to put both sides to the second power, yes? No, I think, what did we put, or what did I put? Put both sides to the nth power, yes? And that might have seemed weird when we started this because everything we did was squares, yes? But what's the root for this? 3. So we won't use a power of 2. We're going to use a power of 3. So because it's a cubed root, we're going to use the third power to both sides. Because the third root in third power, just like with our square root and square, because the third root would be 1/3. We're talking about 1/3 times 3, which will cancel out, telling us that we have 5x minus 2 is equal to 12 cubed. Which is 1,728. 1,728, which, again, we could type that into the calculator and it would give us the answer. Guys, we don't have to do much more of this. Now we just need to solve. Well, at this point here, we would add 2 to both sides. And if we add 2 to both sides, we'd get that 5x is equal to 1,730. And last but not least, we would divide both sides by 5, telling us that x is equal to 3 would be 15, 4 for 20, and then I think it's 2. 0 carry the 1. No, it's going to be bigger than that. This 15, 3, 23, 4. 30 is 346. Sounds better. 346. This third time I've done this today. Any questions on this here? Now, none of the rest of these that we have here are any different than what we did at the beginning, but these here, we're just using cubed roots instead of square roots. So instead of squaring both sides, we are cubing. And that's it.